Here we have a problem on logarithm. That is, we have to evaluate the value of this logarithmic expression. Okay, now let me start evaluating this expression. Okay, in my first step, what I'm going to do is I'm going to use the power rule of logarithm in the first term over here. Okay, what is the power rule of logarithm? Okay, let me write it over here. That is log base a of m to the nth power. Okay, here the argument of a logarithm is a power. Whenever the argument of a logarithm is a power, what we can do is we can move this exponent n in front of the logarithm, and it has to be multiplied by the logarithm. Then we get n times log base a of m. Okay, now we can consider the same power rule in reverse order. That is, there is a value multiplied in front of the logarithm. Now what we can do is we can move this value n as the exponent of this argument m. Then we get log m raised to the power n to the base a. So the same thing we can do over here for this value, because the value 1/2 is multiplied over here in front of the logarithm. Now we can move this value as the exponent for the argument of the logarithm 25. Then we get log base 10 of 25 raised to the power of 1/2. And we can keep this negative sign as it is. The same thing again. So here there is a value multiplied in front of logarithm. These two can be moved as the exponent of the argument of the logarithm. Then I am getting log base 10 of 3 to the second power. We can keep this one as it is, log base 10 of 18. Okay, now log base 10, this 25 can be written as 5 squared raised to the power of 1/2 negative log base 10 of the value of 3 square is 9 positive log base 10 of 18. Okay, now here we can consider the power of a power rule in exponent. Let me write it out here. Let me consider base a raised to the power of m. The whole stuff is raised to the power of n. Okay, so here the base is a, we have exponent m, and for this complete stuff again we have exponent n. Whenever we have two exponents like this, what we can do is we can multiply the two exponents, that is m times n. This is a power of a power rule in exponent. So here also we have the same stuff, that is we have base 5 and exponent 2, and for this complete stuff we have exponent 1/2. Okay, now what I can do is I can multiply the two exponents over here. Then I'm getting log base 10 5 to the power of 2 times 1/2 negative log 9 to the base 10 positive log base 10 of 18. Okay, now this 2 will cancel out. Then we get log 10 of just 5. 5 raised to the first power is just 5 negative log 10 of log base 10 of 9 positive log base 10 of 18. Okay, now let me consider the coefficient rule of logarithm. That is log base a of m negative log base a of n. Okay, here I subtract two logarithms with the same base, that is a. Whenever I subtract two logarithms with the same base a, I have to write a logarithm with whatever base I have for the two logarithms, and I have to divide the arguments. Then I am getting m over n. This is called coefficient rule of logarithm. Here we have subtraction of two logarithms with the same base 10. Now what do we have to do for the first two logarithms in this expression over here? So I have to write a logarithm once with the same base of what I have for the two logarithms, and now I have to divide the arguments 5 and 9 according to the coefficient rule I've explained over here. That is we have 5 over 9 positive. We can write this logarithm as it is. It is log base 10 of 18. Okay, now what I can do is I can consider the product rule of logarithm, that is log m to the base a positive log base a of n equals to, okay, here I add two logarithms with the same base. Whenever I add two logarithms with the same base, what I have is I have to write a logarithm with the base of what I have over here. Now I have to multiply the arguments m times n. When I subtract the two logarithms with the same base, I have to divide the arguments. When I add the two logarithms with the same base, I have to multiply the arguments, because here we add two logarithms with the same base 10. So now we have to use the product rule over here. That is we have to write logarithm once with the base of what we have for the two logarithms, and we have to multiply the arguments. So that is 5 over 9 times 18. Okay, now 9 goes into 9 one times, and 9 goes into 18 two times, and here we have log base 10. 5 times 2 is 10. Okay, here in this logarithm, the argument is 10 and the base is 10. In a logarithm, if the base and argument, both of them are equal, then the value of such logarithm is 1. So the evaluation of the given logarithmic expression is 1.